Hi students, welcome to today's class. Today I am going to explain a few problems from differential equation which can be solved using short trick methods. Okay, then let us see the first problem. The first problem of today's class is x dy plus y dx is equal to x dy minus y dx by x square plus y square. How to solve this problem? So, if we start doing this using variable and separable method, so it takes somewhat time. So, I already in the previous class I have explained about then how to write this. This is how to write down x dy plus by y dx. This is of the form u into v formula, by parts formula, that is derivative of xy. Okay, very nice, derivative of xy. See here, if it is x dy minus y dx is there, x dy minus y dx is there in the numerator. If it is by x square is there, that means if it is x dy minus y dx by x square is there, you can write down this is derivative of y by x, you can write it as. Then you by this is a division rule, y by x, x into dy minus y into dx by denominator x is there, here also x square will there. But here x square is not there. Then how to do that? So, divide the numerator and denominator with the x square. So, that is equal to x dy minus y dx upon x square by x square plus y square upon x square. Okay. So, I divided the with x square both numerator and denominator. So, this is a derivative of xy. So, this up to here you can write a derivative of y by x by. Here x square will get cancelled. This is 1 plus y square by x square. This is y by x whole square. Understand? So, this is almost the required format. Then we can take the integrals on both sides. So, here integral of derivative of xy is already we know. So, both will get cancelled xy. Now, coming to here, see what is the integral of 1 by 1 plus x square dx. This is tan inverse of x. With respect to x you are doing integrating, therefore 1 by 1 plus x square is equal to tan inverse of x you are doing. If it is 1 by 1 plus y square dy, this is a tan inverse of y, you can do it down. That means, if it is y, here also y, tan inverse of y. Here it is x, tan inverse of x. Understand here. So, here also you are integrating this with respect to y by x. Therefore, this is a tan inverse of y by x plus c. This is your solution. Understand? Very nice problem this is. The only thing is here you have to get derivative of xy. Here whenever it is x dy minus y dx or y dx minus x dy, if it is there, then you have to think about how to write it in the quotient rule, derivative of y by x or derivative of x by y. So, afterward the problem will become very easy. I hope that you understand this solution. Let us go for next problem. Welcome to this second problem. The second problem is solve x plus 1 times y by x plus sin y whole into dx plus x plus log x to the base c plus x cos y dy is equal to 0. Then how to do this problem? The first thing is, so you multiply this y by x with these two terms and dx with these two terms. There also dy to all these three terms. Afterwards, we will grouping together. Okay. Then let us see here. If you multiply y by x with this, x will get cancelled. So, you will get x into y by x, that is equal to y you will get, of course, dx is there plus. Okay, 1 into y by x, that is equal to y by x, of course, dx is there plus sin y into dx plus. There you multiply with dy to these three terms, that is equal to x into dy plus log x to the base e into dy plus x cos y into dy is equal to 0. Okay now. Next what we have to do is now we have to grouping the terms together. Grouping the terms. Grouping the terms means what? See here. Here y dx is there. Here x dy is there. You can group together. Next one, trigonometric functions. So this is sin y dx. This is x cos y dy. Those two are some trigonometric functions. Next we can group these two terms. This is y by x dx. This is a log x to the base c dy. Like that you have to identify the terms which are to be grouping together. Okay, so let us rewrite these terms y dx plus x dy. Okay now, right, plus these trigonometric functions, that is what, sin y dx plus x cos y dy. So these two terms I grouped together. Again these two terms, those are what, y by x dx plus log x to the base c dy is equal to 0. So these two terms, all the 6 terms I grouped together. Okay now, so very nice, right. This anybody can say, is a small children also can say y dx plus x dy. So this is equal to derivative of xy. What about this? What about this? So if you observe here, this is also a by parts formula. Sin y cos y is there here. Sin y cos y there. X is there. X derivative is 1 here. That's why. Can I write down this is a derivative of x sin y? Derivative of x sin y. Is it right? Let us check it. Let us check. So u into v, x into, so sin y derivative cos y, again y derivative dy, plus sin y into x derivative 1 into dx. Understand? Right. Coming to here, this is also derivative of log x derivative is 1 by x. So can I write down this is a y into log x to the base c, that is equal to 0. Why? Because y into log x derivative 1 by x, again x derivative dx, plus log x into y derivative dy. Understand this? So very nice. So everything is over here. So let us integrating on both sides. So integrate, integrate, integrate. So what you will get? So this you will get xy, you will get x sin y, we will get y log x to the base c, of course c, constant of integration is c. Okay, very nice problem this is. The only thing is grouping the terms and writing in the form of as a single quantity, that is a derivative of y log x to the base c. I hope that you understand this solution. Let us go for next problem. Welcome to this problem. Here the problem is solve x cos x minus y sin x dx is equal to x by y sin x dy. Okay, now then how to do this problem? So this also just by grouping the terms. Okay, first you multiply inside the left hand side. What happens you see here? So this is equal to xy cos x minus y sin x into dx is equal to x sin x dy. So dx also you separate it. So this is a xy cos x dx minus y sin x dx is equal to x sin x dy. Okay now, right. Then next what you will do now. So here xy you multiplied with y here, y sin x. Next what you will do? So let us take this y sin x to left hand side. Let us see what happens. Okay now, so this is equal to if you take here left hand side, xy cos x dx is equal to, so this is a y sin x dx plus x sin x dy, x sin x dy. Is there anything to be taken common outside? So we can take, see here, this is xy cos x dx. You can take here sin x, you can take common outside. So if you take sin x common outside, what happens here? Y dx plus x dy, right? Very nice, y dx plus. So whenever you see this y dx plus x dy, So, this is nothing but xy into cos x dx is equal to sin x into derivative of xy. Okay now. So, very nice. So, that is a derivative of xy. Now, what you have to do is now take xy to right hand side, sin x to left hand side. Cos x by sin x, cot x. So, this is equal to cot x dx. This is equal to derivative of xy by xy. Okay now. So, all the grouping of the terms is completed. Now, coming to here, integrating on both sides. What is integral of cot x? Integral of cot x is equal to log of sin x is equal to log of xy plus log c. So, why it is log of xy means, see here we are deriving integrating with respect to xy. So, if it is there 1 by x dx, we are writing log of to the modulus of x to the base c. So, here also you are integrating 1 by xy with respect to xy. That is why log of xy got write out. So, you can remove these logarithms on both sides, that is equal to sin x is equal to cxy. This is your final answer. So, that is log a plus log b is equal to log of a into b, okay, log ab. So, this will be your final answer. So, very nice problem this is, just by grouping the terms you can get easily answer, okay. So, let us move to next problem. Dear students, welcome to this problem. So, the problem is solve y to the power of 4 dx plus 2x y cube dy is equal to y dx minus x dy by x cube into y cube. So, then how to solve this problem? This problem also can be solved using a intelligent grouping of the terms. Then how to grouping the terms? Here different methods are there to grouping the terms. The first thing what I will do now, so take this right hand side terms to left hand side term. So, what happens you see here? So, this is equal to y power 4 dx plus 2x y cube dy plus I will write down this as a x dy minus y dx upon x cube y cube is equal to 0. So, this is a y dx minus x dy. So, when I am taking to left hand side, this is a x dy minus y dx by x cube y cube is equal to 0. Now, what we will do now? So, you x cube y cube is there, no? So, multiply with x cube or y cube on both sides. Then what happens? This is equal to x cube into y to the power of 7, y power 4 into y cube, y to the power of 7 dx plus 2 into, so this is x cube into x to the power of 4 and y power 6, x power 1 x cube, that is x power 4, this is y power 6 plus x dy minus y dx is equal to 0, right. If you observe here, x dy minus y dx is there, no? We know the formula. So, derivative of x by y is equal to how much? Y dx minus x dy upon y square. The derivative of y by x is equal to x dy minus y dx by x square. So, if you observe here x dy minus y dx by x square is there. So, here x dy minus y dx by x square should be there. Is it x square is there? Not there. That is why what you will do? So, what you will do now? Divide with the x square on both sides. Divide with x square on both sides. So, here first here we want x square on denominator here x square. That is why dividing with x square on both sides. So, if you divide with x square on both sides, what will happen here? So, this is a xy to the power of 7 dx plus, so this is a 2x square y power 6 plus x dy minus y dx by x square is equal to 0. So, I divided with x square. Up to here what can you write down? You can write down derivative of y by x, okay, over. Now, coming to here, so this is equal to x power 7 dx plus 2x square y power 6 plus derivative of y by x. But here you have to think in a very logical way. So, here what I am going to do is there any, can you grouping these terms? Can you group these two terms here? So, we cannot group. So, this is here you will get dy here also dy. Can you group these two terms? So, it is somewhat difficult to do group these. That is why one logical thing is, one more thing is, you can write down here y by x, no problem. Why? Because if you write y by x here, nothing wrong in it. Why? Because here if you take integral, you can get log of y by x, you can get. No problem. If it is without this, you can get y by x. If you write down divided by y by x, logarithm of y by x you will get. Okay now. So, for that if you divide with here also y by x. Here also y by x you divide with y by x. Let us see what happens. So, here x will go in the numerator, that is x square into y power 6 dx. Here x go in the numerator. So, this is equal to 2x cube into y power 5 dy. Right. If you observe here, x cube derivative is 3x square. Here 3 is not there. X cube derivative is 3x square, 3 is not there. Y power 6 derivative is 6 into y to the power of 5. Here 6 is not there. Of course, 2 is there. If it is 2 times 3, the problem will be over. That's why multiply and divide with 3. What happens? You see here 1 by 3 into. So, this is a 3x square y power 6 dx plus. So, this is equal to x cube into 6y to the power of 5 dy plus derivative of y by x is equal to 0. So, here if we observe, x cube derivative is 3x square, y power 6 derivative is 6y to the power of 5. Okay. Now, this can be written as 1 by 3 derivative of this x cube into y to the power of 6. So, this plus derivative of y by x is equal to 0. Now, you can integrate. Now, you can integrate easily. Okay, now, so what will be your answer? So, this is equal to 1 by 3 of x cube plus y power 6 plus this is of course log of y by x is equal to log c or simply c. So, that will be your final answer. Okay, right. So, very nice problem. This is a very logical problem. So, you can solve it in a logical way. Okay. I hope that you understand this solution. Let us go for next problem. Welcome to this problem. So, it is also a very nice problem. Solve dy by dx is equal to y times f dash of x minus y square by f of x. Then how to solve this problem? Okay. So, the one thing what I will do now, just to do the cross multiplication. So, this is equal to f of x into dy is equal to, so y into f dash of x into dx minus y square into dx. Okay, now, right. Now, what I am going to do is take minus y square dx to left hand side, f of x dy to right hand side. So, this is a y square dx is equal to y f dash of x into dx minus f of x into dy. Okay. Put dx here only, take y square to right hand side. So, this is equal to dx is equal to y into f dash of x into dx minus f of x dy whole divided by y square. So, see here. Now, can we group this term? Can we write it as a single differential? Can I write it as a single differential? Yes, we can write it as how? So, this is equal to derivative of by y f of x. Can I write it as, see here, u by v formula, y into f of x derivative f dash of x dx minus f of x into y derivative 1 into differential of y is dy. So, this is equal to dx. Very nice problem. Okay. So, just idea you will, so you may ask one doubt, sir, how you will get this type of ideas means, by if you go on practicing these problems, automatically you will get that idea how to grouping the terms automatically will get. So, here the thing is, first we cross multiplied and we have taken like this, and here y square is there, no, to minus y square to this side. So, all f of x come to should in one side, f of x and f dash of x, whatever may be that. So if you see that this is just like a by parts formula. If it is y is there, here y square should be there. If it is first term x is there, x square should be there. Okay, now like that it should be y square should be there. That's why already here y square is there. So bring to y square to right hand side. Okay, now so you will get derivative of f of x. Okay, now if you integrate this, you will get x is equal to f of x by y plus c. So this will be your final answer, constant of integration. This is a family of this is a equation of the family of lines whose family of curves whose solution is this, dy by dx is equal to lines. Okay, I hope that you understand this solution. So dear students, I hope that you enjoyed today's class. With some more problems, I will come to your tomorrow's class. Until then, all the best.